Hi everyone, today we are very happy to share our research as emotional geographies. This project looks at how AI tools check our cities. Our teams come from Tongji University, but let's go Architecture UCL, and the Chinese University of Hong Kong. We want to talk about a big problem in smart cities. Today we use AI to measure if a city is good or safe, but we often forget that many cities like Hong Kong and New Delhi have a long history of colonial rules. This history still shapes how the city looks today. We want to see if AI tools accidentally repeat these old and fair ways of thinking when they look at cities in the global south. To understand this, we must look at the Garden City model. Ebony Howard imagined these cities as perfect places where nature and people live together. But when this idea was used in colonies like Hong Kong and New Delhi, it was not for everyone. In these cities, the garden city design was used as a tool to separate people. For example, in the quiet street of Kowloon Town or the big roads of New Delhi, the design was built for the rich and the elite. This design created deep levels of division based on race and class. These divisions are still there in the city today. Now, we have AI that promised to measure these inequalities, but we argue there is a gap in understanding. Most AI models for cities are made using Western rules. These rules value things like order visibility or something like this, but in the post-colonial city, this is a problem. The AI might think a quiet elite area is good, while a busy, crowded neighborhood is messy or unsafe. This means the AI is just repeating an old colonial way of looking at the world. Our research employs a tripartite framework: machine vision, social emotion analysis, and human adjudication. First, to see how social levels still exist in these city shapes. Second, to test if AI model carry Western basis. Third, and the most importantly, to find where the AI numbers do not match the real feelings of people, especially women living there.
Now, let us move to the core of our methodology, the tripartite framework. Our goal was not just to run an algorithm, but to create a critical dialogue between computational data and lived experience. The process is divided into three key layers. First, data acquisition. We collected multimodal data sets, including Google Street View for physical morphology and geotagged social media posts for effective expressions. Second, the processing layer. We employed computer vision to detect gender presence and infrastructure quality while simultaneously using a bird based NLP model to calculate sentiment negativity scores. Third, and most importantly, the human in the loop validation. Instead of accepting the AI indices as final, we subjected them to a decolonial critique. We cross referenced the algorithmic outputs with historical archives and feminist geography theories to identify effective dissonance, those moments where the machine reading of safety failed to match the community's reality. This framework allows us to reposition AI as a tool for inquiry rather than just a tool for measurement. Before we dive into the technical pipeline, let us look at our urban laboratories. We selected Hong Kong and New Delhi because they represent two distinct morphological archetypes of colonial planning. In Hong Kong, we contrast Kowloon Tong, a low density garden city enclave designed for the elite, with Sham Shui Po, one of the world's most densely populated districts, categorized by organic growth and street level vitality. In New Delhi, we examined the Lutyens Garden City, defined by imperial grandeur and monumental boulevards, against Karol Bagh, a high density commercial and residential hub. By selecting these contrasting pairs, the planned garden city versus the high density organic district, we can test if AI audits respond differently to these opposing urban logics. These sites are not just geographic locations, they are morphological archetypes used to validate the sensitivity of our algorithmic framework. Methodologically, we integrated Google Street View imagery to capture physical infrastructure and foot traffic. We geotagged social media data, specifically Twitter, to extract effective expressions. We process these through computer vision for pedestrian detection and BERT models for sentiment analysis. Crucially, we treat computational findings not as absolute truth, but as one layer of evidence to be contested by historical archives and critical urban theory. Looking at our preliminary results, we see a stark paradox. In Hong Kong, the planned Garden City area showed a significantly higher female proportion, 60%, compared to lower income areas. However, in New Delhi, the relationship was inverted. Despite being a planned area, female presence in the Garden City was marked low at 18.2%. This suggests that planning typology alone does not guarantee gender equity, social impact is deeply mediated by local labor and cultural context. The most telling data lies in the gap between infrastructure and perception. New Delhi's garden city scored high on the Safe Infrastructure Index at 69.2%, yet it recorded much more negative gender safety perceptions compared to Hong Kong. This proves a critical failure of purely metric based audits. Superior physical infrastructure like wide open sidelines does not necessarily translate into a greater sense of safety for women.
Let's look at a specific failure of the model. In Kowloon Tong, the AI detected a high female presence and signaled equity. However, human age equation reveals that these women are predominantly South Asian domestic workers. They occupy the space as underprivileged laborers, not as agents of public belonging. Here, the AI collapses presence into empowerment, effectively erasing the underlying labor hierarchies and racialized servitude. Similarly, in Lutyens Daily, the model assigns high safety scores to the elite aesthetic, wide boulevards, and gated compounds. However, for the local women, these empty, highly controlled spaces can feel exclusionary and isolating. The very feature that makes a street algorithmically ideal under the Eurocentric matrix are often the ones that lead to social vacancy and a lack of communal oversight. Conversely, high-density districts such as Shamshui-Po were classified by the algorithm as disorderly or risky. However, qualitative findings indicate that women often report feeling safer in these areas. This can be explained by the concept of eyes on the street, where strong community presence and informal social surveillance in dense neighborhoods contribute to a heightened sense of safety. The algorithm, which prioritizes visual order, perceived cleanliness, fails to capture these social dynamics. This suggests that what may appear as messiness can in fact function as an important form of informal safety infrastructure.
Of course, our study faces constraints. We deal with data voids and informal settlements, binary limitations of gender classification models, and temporal staticity of street view imagery. These are not just technical bugs, they are reflections of the coloniality of data that we must actively work to mitigate. Moving forward, we propose a roadmap for the colonial AI. This includes co-designing safety metrics with local communities, fine-tuning models on culturally diverse datasets, and shifting from binary classifications to presence counting. We must ensure that the algorithmic outputs are always cross-validated with human lived experience. In conclusion, our research has repositioned the AI audit from an authoritative assessor to a critical muckraker. The failures of the AI to align with lived experience are not errors, they are analytical evidence. They illuminate the limits of algorithmic reasoning and chart a path towards more situated post-gender and post-colonial urban metrics. Thank you.